version of the STAAR test for Algebra 1. Alright, first one here, let's get into it here. Savings account balance can be modeled by the graph of the following linear function shown on the grid. What is the rate of change of the balance with respect to the number of deposits, right? So what you need to do here on this one, we need to recognize here when we see rate of change, it's basically asking for your slope. All right, on your STAAR formula chart, you got the slope formula, y2 minus y1 over x2 minus x1. That's usually used when they give you ordered pairs, but an easy way to find slope when they give you a graph is to count the rise over run. So what we're going to do here is we're going to see how many units up, and we're going to put that as a fraction, the ratio of how many units over here. So it looks like it's going up 100 and then over 1 unit right there, up 100 in your dollars and then over 1 deposit right there. So we could say it's going to be this first option here, $100 per deposit there. So they start us out with one that's pretty easy there. Rate of change, that's slope. Okay, so we'll move on here to question 2. Which expression is equivalent to 2x squared plus 4x minus 6x squared plus 9 minus 6x plus 3? Alright, so basically this is asking for us to simplify it. All these answer choices are all simplified versions of this thing theoretically here. So we need to be kind of careful here. We got a bunch of parentheses. Usually when you got parentheses, sometimes you got something to distribute here. In this case, you don't really have much to distribute. You have a 1 technically, but that doesn't really change anything. So we don't usually write that step. Now over here, you got this minus and then all of this stuff in the parentheses. So you do have to be kind of careful with this. What I'm going to do here is I'm going to write a little -1 right there. All right, the 1's implied to be up there. So we essentially are distributing the negative. So I'll make that minus 6x and then I guess minus 3. Okay, and then I'm just going to rewrite everything else. 2x squared plus 4x minus 6x squared and then plus 9. Okay. So after this here, we want to combine our like terms. That means x squareds with other x squareds, regular x's with regular x's, and then the regular numbers without any variables. We call those constants, so constants with other constants. So I'll start out with the x squareds. Looks like I got 2x squared and negative 6x squared. So when I simplify that, that'll be negative 4x squared. Okay, the regular x's here looks like we got 4x and then minus 6x. So when you add those up, I believe you get negative 2x. Then the last but not least, you got 9 and negative 3. When you combine those, you got plus 6. And looks like option G here is our best answer. So they kind of start us out there with 2 relatively easy questions. Now, on the 2016, I'm making these videos here. It is the fall of 2016 here. So they are allowing us to use Desmos. So that's one of those apps on the iPad there where you can do a lot of different things, a lot of graphing and stuff. So some people with Desmos, if you want to do this to go and check your answer, you could type all of this into Desmos as one equation, and then you could type this in as your second equation in Desmos and see if those overlap to check your answers. So that'd be a powerful tool. Really, we don't need to do that. It'd take more time than to just actually solve it by hand. But anyways, just keep that in mind. A lot of these problems you can do something similar to that there. So this next one here, this one's a little interesting here. So a lot of words here. We'll break it down. Baseball fans can buy tickets for seats in the lower deck or upper deck of the stadium. Tickets for the lower deck are going to cost $42 each. The ticket prices for the upper deck are 75% of the cost right there of the lower deck. So what that is saying there is whatever those $42 tickets are, we're going to multiply that by 0.75. All right, and you're going to have a calculator on the test. So we'll just punch that out here. 42 times 0.75. That's coming out to 31 and a half. And that sounds about right there. That's a little bit less than the upper or than the lower deck. So that's that cost. going on right there. So we got to figure out some way how to incorporate that cost and then also the $42 each. Okay, which inequality represents all the possible combinations of X, the number of tickets for the lower deck and the number of tickets for the upper deck that someone can buy for no more than $800. That means no more than, we need to be less than 800 bucks. All right, and actually, so no more than also means you could be at exactly $800 there. So if we were at exactly $800, we're good. So we're going to go ahead and say less than or equal to. So we got to go ahead and figure out how to incorporate some of these things here. So I guess they are saying X is the number of tickets for the lower deck. So that's the more expensive tickets. So I'm going to say $42 per one of those lower level tickets. And then we just went and punched out that the upper level tickets were $31.50. So I'll put that there in front of Y. So best option looks like it's going to be here. Oh, that's going to be B. Look out for common things. They might have, like I guess this one here, it has 56Y, so that's more expensive for the, the upper deck, which doesn't make any logical sense. And then these other ones here are saying we need to be greater than 800, which doesn't make sense if you're dealing with the budget. So definitely B is our best option there. So make sure you use process of elimination. That might help you find some of your answers there. All right, next one here, the function p is in the form of ax squared plus c. The values of a and c are both less than 0. Which graph could represent p? So anyways, a couple things. You should have learned this at some point. Your a value of a quadratic, that determines if, well, first of all, it determines how wide or how narrow your graph is, but I don't think any of these graphs are referring to that. A can also affect, if a is greater than 1, or I'm sorry, greater than 0, that means your graph opens up. That means right here, this means you have positive a values. If you have positive a values, that means the graph opens up. Okay. Now, if you have a values less than 0, it means you're going to have a negative a value, which means the graph opens down. Okay, so they are saying A and C are both less than 0, so we know that our graphs are going to be opening downward. Basically, both of them should be pointing down, so we can obviously eliminate answer G right away. So now the C value, that kind of affects how high or how low your graph is. It's technically the y-intercept of your graph. So if C is, they're saying here in this case, less than 0, that means the C, or let's say the y-intercept is less than 0. It's going to be going down. So some type of low C value. So the only option I see right here, option F, your y-intercept is positive 1. We don't like that. Option J here, the y-intercept, that's 0. We don't like that one. So obviously, answer's got to be H. So pay attention. The A affects the graph opening up or down. The C is basically how high or how low the graph is. It's technically your y-intercept. So go with the lower of those two graphs. All right, next one here. The table represents some points on the graph of a linear function. Which function represents the same relationship? All right, I'm going to do this in two different ways here, so you can have multiple options here. So we're trying to find which equation matches up with all of these numbers here. Now, unfortunately, they put a bunch of these 0.5 things here. So if we type all of these equations into our calculator, those probably won't show up on our table values. If we're using one of the TI-84 calculators, there is a way that you can make decimals pop up in the table, but it's kind of tricky there. So I wouldn't worry too much about this. So one way I'm going to do this here is use my point slow formula. I usually abbreviate it with PS. That's the y minus y1 equals m times x minus x1 here. So that helps us write equations right there. And then notice all of these are in y equals mx plus b form. So we probably need to take our point slope form, whatever it is, and then eventually simplify it. Okay, now x1, y1 is just a random point. I'm probably going to choose something easy to plug in, maybe something like that right there since it's got a 0. But the only problem is I don't have m. And m, that's supposed to be your slope. All right, now on your formula chart, you should have this thing here, y2 minus y1 over x2 minus x1 there. So we need to punch out what our slope is. Okay, so really you do that just by choosing two random numbers. It doesn't matter which numbers they are. I'm going to go with maybe some of these here because I guess plugging in 0 is not too bad. So you're going to go your y's in the numerator. So I'm going to go negative 7.5 minus 0, which is easy to punch out. But then I have to go in that same order for the second point. So I got to go negative 1 and then minus negative 3.5. Minus a negative is the same thing as adding. So I'm going to say plus 3.5. I'm going to clean this thing up. Doesn't look like it's going to come out nice. It's negative 7.5 over, I guess, 2.5. And then if you punch that out in your calculator, that should simplify down to negative 3. And that's your m. Okay, so we could honestly eliminate pretty much every one of these answer choices. Choose the one that's got the negative 3 right there. So honestly, we could probably stop right there if we recognize that. Now, if we want to get the rest of it, which I'm going to show you here real quick, you can go and plug that into your point slope formula using your slope and then a random point. So I'm going to use 3.5 or negative 3.5 comma 0 when plugging back in. So let's do this here. We got y minus, what's our y value? 0. So y minus 0, which cleans up rather nicely. We got negative 3 for the slope. And then our x value that we're plugging in is negative 3.5. So that'll change that to a plus right there. Since you're plugging in minus a negative right here, we'll change it to a plus. You got to go opposite sign there. Okay, so that simplifies. That's 3, y right there, and then negative 3. We got to distribute that. So it'll be negative 3x. And then if you want, if you're not comfortable with your decimals, you can type in 3 times 3.5 gets you 10.5 right there. So that'll be minus 10.5. And then obviously that matches up there with answer A. Okay, so that's how you get the full equation. Now I was walking around today helping out a couple of students here. I had one student actually using linear regression. So if you want to do something like that, you would go into your calculator here. I'm going to try to pull this up. Hopefully I don't freak out my computer. So you could go use linear regression by hitting the stat button, edit, and then typing in all of those coordinate points right there. So I'm actually going to do that here just to show you guys. So sometimes this is kind of slow here. Negative and 7.5 for one of them. We got negative 3.5, negative 1. And by the way, if you understand this problem and you don't want to see this, you can probably just skip on to the next question. 5. So I thought this was a rather clever way to get the equation here punched out. Just using linear regression, getting your calculator to just tell you the answer without having to really think, oh, whoops, that is 7.5, negative 7.5 there. Then we got negative 16.5 and then negative 21. Obviously, this takes a little bit of time to do it this way, but I guess it's one way you can figure out if you're doing it correctly. After you do that, you hit stat. You go over to this calculate screen, and then these are all your different regressions. And the one we want to use, since they told us it was a line right here, it says a linear function, we're going to use a linear regression. Then you could scroll down here to the bottom, you hit calculate, and then your calculator actually figures out the line that goes through all those points. Usually we use this when our data is not all nice ordered pairs and maybe it doesn't go through a straight line. This gets us our line of best fit here. But all these points actually lie on a true line. So therefore, this is all these numbers come out real clean. They're not weird decimals. So that's another way you could do this type of problem. You don't have to do it that way. Honestly, I would just work it out by hand, but whatever way you would like to do it. So there we go. So that's it for the first 5 problems. I'm going to pause it here and then continue on in another video.